Okay, so let me begin this. Let me say, yeah. So to set the agenda for the day, so we get about an hour, and then we will start off with a basic introduction about chatbots. I think most of you would have already seen a chatbot at work or interacted with a chatbot, but then we'll go a little bit ahead, and then we'll also figure out so what kind of chatbots are we dealing with. And then we will also briefly talk about NLP and NLU, natural language processing and natural language understanding. And we will also pick one easy way of one easy way of getting acquainted ourselves with what does it mean when we say a chatbot has NLU with it. And then the exciting part about, I'll show you a working demo of a chatbot. And then to post this session, I'll also be able to put that code out on GitHub, and you should be able to pick that code and then also do your experimentations with it. And then we'll also open up the forum for a Q&A as we move towards the end of the session then. So there are a couple of chat things that have come in. Let me quickly go through it. Okay. All right. Yeah. So I think those were the responses to whether my screen is visible. Okay. So let me begin this session with this. So a chatbot, a Wikipedia definition of it just says that a chatbot is a software application used to conduct an online chat conversation via text or text-to-speech in lieu of providing direct contact with a live human agent. So this is a very intuitive understanding, and most of us also have this kind of an understanding. But a chatbot is much more than that. So it's very easy to understand a chatbot, but it's really very hard work to make a chatbot really work. So in that, these chatbots are now the most prominent driving force behind a very wide umbrella of applications called as virtual agents. And Gartner also predicts that almost 25% of AI implementations will actually be virtual agents. So when I say virtual agents, so this can be, so you call up a company and then there is somebody else at the end of the line, so that can be a virtual agent. Or maybe the time is up and then all the leave approvals that are pending in your pipeline gets automatically approved, so that can be a virtual agent. Or there can be an agent that reminds you, in not just an alarm kind of a way, but reminds you better about what kind of doctor visits you have or what kind of medication, or as it interacts with your devices, so will it be able to prompt you about variations in your health or any impending diseases that can occur and all those kinds of things. So virtual agents are now almost everywhere. And they will continue to be the biggest implementation or application of artificial intelligence. And also these chatbots also, there is a very interesting term about conversational commerce. So this conversational commerce, chatbots kind of drive the conversational commerce. So when I say conversational commerce, so it's about, so when you go to, so right now, how is our online purchase experience? So we go to an online website, pick a product, we already know what are we searching for, we pick that product, we purchase that product, and then there are some machine learning algorithms, so which kind of gives you some kind of recommendation, or maybe sends out a certain kinds of ads to you and all those kinds of things. But then at no point in this whole workflow, a customer is actually interacting with the brand. So if a chatbot can facilitate that kind of an interaction, so then it also has, and then we say it's driving conversational commerce, as in say I go to Amazon to buy something, but during the purchase flow, I'm actually interacting with the brand's bot, and through that, the bot may be able to recommend a better product for me, or may be able to cross-sell, upsell something to me, thereby adding a better value to me, or maybe it may also say that it might help in increasing the ticket value by also suggesting a different thing, different item apart from what I'm trying to purchase, and that is conversational commerce. So Gartner predicts that 25% of the digital workers, I mean, in 2021, so we are very close to it, will use virtual employee assistants daily. So we are already doing it on and off, but then it's going to be ubiquitous. So chatbots, so not just at an understanding of, okay, so there is a, so you just go to a chat, you try to chat, and then something happens. That need not be the only conversation. A chat mode conversation need not be the only conversation. So these chatbots can be sitting behind any kind of interface, need not necessarily a conversational interface, and they can actually be doing what a bot needs to do. So they can sit behind your searches, they can sit behind your clicks, they can sit behind your speech, they can sit behind your recording devices. So these bots can be anywhere a natural language is involved. So these bots can basically sit there. Looking at it as a conversational piece, looking at it as something wherein you interact with it through some sentences is only a limiting way of it. But currently the implementations are mostly like that. So you're looking at chats through those kind of human conversations that happen with a chat. Okay, so now, yeah. So there are basically two kinds of chatbots. So one chatbot operates on a set of rules. So this is basically a typical decision tree kind of a chatbot, wherein so the questions are already hard coded, the menu items are already hard coded, and then you just move through the menu item, and then something happens at the end of the conversation. So these kind of chatbots we have already definitely used. So you call a bank, you get that annoying menu about press one to do this, press two to do this, press three to do this, and then so that's very easy to code. So there you will have some kind of an elaborate decision manager, an elaborate if-else structure, a glorified if-else structure, wherein you say, okay, so press one if you are hungry, and press zero if you are not. So if you say zero, it says okay, bye. If you press anything else, it's going to go back to the same menu. Or if you say one, then an elaborate pizza ordering menu will come up to you. So these kind of IVRs are the general implementations of chatbots. So they are also chatbots. But that you see that anybody who has worked with some kind of programming will see that implementing a chatbot that works on a set of rules at this point of time is pretty easy and pretty commonplace also. But what we are really talking about is this, and also today's point of conversation is this AI-powered chatbots. So artificial intelligence-powered chatbots. I think artificial intelligence is one of the most used words. I don't know, maybe COVID has already overtaken it, but then yeah, so artificial intelligence is one of the most overused words, and then you would have already come across it. So in a very single sentence, so what is artificial intelligence? So if a system is able to take some decisions in spite of some ambiguity of instructions, then we say that it's an artificial intelligence program. And there are many ways of implementing artificial intelligence programs. And because we're in the context of talking about chatbots, we are talking about an artificial intelligence which kind of understands language and then also commands, and then it can also learn from users' experience, and it can mimic a human interaction, conversational, contextual. So those are the kinds of chatbot that we are kind of talking about right now. Okay, and then, so these AI-powered chatbots at their best, okay, should actually pass the Turing test. Very interesting test there. So this Turing test was devised by Alan Turing in 1950 itself. Right? So all of the AI-enabled solutions that we talk about are actually trying to match or trying to pass this Turing test. So what does it say basically? Machine's ability, this is a kind of a measure of a machine's ability to exhibit intelligent behavior or be indistinguishable from that of a human. So the test specifically says that if there are more than two participants in a conversation where one of them is a robot, then a person who is evaluating this conversation or a third party who is listening in on this conversation, so he will not be able to single out who or which one is the robo in this conversation. So then we say that this chatbot or this chatter robot or this robot has actually passed the Turing test. But the truth as of today is that all the bots that we have, to varying degrees, they fall between these two kinds of chatbots. Either they are, so they might have a little bit more than a regular menu kind of a chatbot, or they might be, they might not be as much as a Turing test, so that it really becomes completely undistinguishable. So what is kind of stopping this kind of matching the Turing test is all the language, natural language processing or natural language understanding is still trying to catch up with poetry, is still trying to catch up with all the metaphors, similes, and sarcasm. So those are the things that we are still trying to catch up with. So once we cross those boundaries of natural language processing and natural language understanding, then it becomes a lot more commonplace to match the Turing test. And also, one more limiting factor, which is not allowing these natural language processing to actually match the Turing test, is not all languages are token-based languages. So when I say token-based languages, most of the Indic languages are token-based, as in you have clear separation between words. So most English is a token-based languages. So most of the natural language processing is built around token-based languages. So when those tokens cease to exist, so then the natural language processing becomes a lot more difficult to apply on those kind of languages. So what does it mean? So when we say that, okay, building an AI-powered bot, that basically means that there should be some amount of understanding of the natural language. So what does that specifically mean? So here, any NLP or any natural language understanding modules or libraries basically look at natural language as language itself as unstructured data, and how do you make sense of this unstructured data? How do you bring out patterns out of it? How do you bring out your feature vectors out of it? How do you bring out your entities as in, so can we easily distinguish between the object, verb, and the subject? So that's what this natural language processing kind of deals with. So there are these two terms, natural language processing and natural language understanding. So very quickly to look at it. So anything that you do with natural language processing, of course, so that is NLP, as in, yeah, so you get a sound bite, you convert that speech to text, so you are processing natural language. So that can be a very huge thing, or you can do from text to speech, you are processing natural language. So a smaller subset of it, wherein once you process that language, understanding what is the intention behind that spoken language is where natural language understanding comes into picture. So this natural language understanding is a smaller part of it. So we speak about chatbots in terms of natural language understanding because, so chatbot is not just about speech to text, look at the text and then process something. Yeah? It's not just about that. It's about understanding the intent behind the sentence that is spoken and then react to that intent. That is what all of us do when we have a regular understanding of a natural language. So that's why we speak of chatbots under the context of natural language understanding. So this chatbot architectures have kind of evolved over the years. It's not really a new topic. So for that matter, one of the first the precursor to all the chatbots that have been available is this ELIZA. So this was basically a pattern matching decision management kind of an engine. So it understood patterns of the natural language, and it had hard-coded branches about how do you take some decision. So it was a step above this regular IVRs kind of a language. And from then onwards, there have been a lot of efforts to this chatbot. And what you see here is, from the 2000s until now, we have actually had a leap and bound kind of an improvement over how these chatbots work. So a lot of factors to this, that is emergence of internet, emergence of cloud computing, emergence of making computational resource as just a commodity, wherein you can just go and buy how much ever you want. So that is where a lot of this natural language processing have moved from a pattern model and a mental model towards what we call as information retrieval, that is extraction of information, and also about deep neural networks. So what do I mean by information retrieval? That is, when I say Virat Kohli is the captain of the Indian cricket team, so understanding that, okay, I'm talking about some sport is the intention. The information retrieval is I'm talking about Indian cricket team on one entity, Virat Kohli as one entity, and then the connection, which is the captain, which becomes one more entity. So extracting that information from natural language spoken is what is now capable when we try to implement these chatbots. So when we talk about chatbots and when we talk about natural language understanding, it's a very vast topic. It's a very huge topic, and people have spent lifetimes building. These libraries and modules around this natural language understanding. So, but what are we specifically doing here? So let me try to kind of condense that down into very easily intuitive, easy ways of understanding that. That is, whenever a sentence is given, so then we need to understand these three main things. That is, one is we need to understand the intent of the sentence. We need to understand what are the entities involved in that sentence. And we need to understand what kind of a response should I give back to this sentence. Yeah. So now if you look at it, so if the sentence is like, how is the traffic today? So here the intent is to seek information. So if I say I want to buy a hair trimmer, then the intent is to purchase something. So if a sentence comes as hello, then the intent is a greeting. And if it's a bye, it's still a greeting, but then an exit or an end of a conversation that we are trying to have. So what are we basically doing here when given a set of sentences? When given a set of sentences, we are basically trying to classify them based on the intent. A classification is a very common machine learning algorithm. So the best way to think about classification is when you get a mail, so there is a program which classifies the mail as spam or ham. So that is a classification. What are we basically doing? We are basically attaching a label to the mail telling that this mail is a spam mail or this mail is not. We are classifying that on two binary labels. But here, the labels of classification just becomes the intent. And I'm classifying each sentence that comes based on the intent of that sentence. So that is the first part of it, that is intent classification. So once the intent classification is done, once I understand what is the intent of it, then I need to extract some information from that, and that is called as entity extraction. So I have taken the same sentences here and I have tried to split that out like this. Hello is an intent called greet, and then there is no entity for it. Similarly, buy, it's just a greet. Yes, there is no entity. I want to buy a hair trimmer. So this buy has kind of triggered the intent called as purchase, but then the entity here that I'm referring to is called as a hair trimmer. So similarly, here it's an information about traffic. So now once I split this, once I get my sentence and understand how this sentence is built, this is where most of the NLU happens, natural language understanding, and then comes the dialogue management. Yes, we have understood what happens in this NLU, and then what kind of a dialogue that I need to have. And that is where the response or the action that comes. So if my program understands that the text is hello and the intent is to greet, then I give back a response called as hi, welcome. And then if it is bye, then I say bye, see you soon, and so on and so forth. What is more important here is, so this is where most of your business logic will sit in the sense that, So if yours is an e-commerce site, and if somebody says, I want to buy a hair trimmer, then the intent is purchase, the entity is hair trimmer, and then what do you want to do? There might be a list of actions that you want to do there. So maybe you want to upsell and show a list of recommended hair trimmers, or based on the user's previous behavior or previous purchases, or you might just show a sponsored purchase. So what you want to do there, the response is still in the hands of the business logic. Similarly with traffic also. So what do we want to do? So how is the traffic today? And if the entity is traffic, then we return back with a response or a map, or it can be anything. So here the response chosen is heavier than usual. I think that's the most common thing that you hear with Bangalore. So every time I see this heavier than usual, I don't know when they took this usual benchmark, right? So it's always heavier than usual. All right. So now why I took this one approach of NLU for a discussion, for the discussion here today, is there are many more ways of implementing natural language processing. Is because this kind of gives us a good segue into the technology demo that we have next, wherein we will look at our first bot, our first chatter bot, which basically accepts a sentence from us, and then it's going to do something. So here we have called our first bot as a poster bot. So what this basically does is, I'm going to interact with this bot, and then this bot will figure out that what is the intention of this guy, and then go and fetch me some posters of a movie title. So how do we do it? I'll come to the explanations of it. So this natural language understanding approach that I spoke about gives a good segue into our next segment of this. So for this, there are a lot of platforms for us. So there are two ways. So I can go about implementing the machine learning, natural language understanding programs, and then I can go about building the chatbot from the scratch. But then this Rasa tries to stand over the shoulders of James. So what it basically does is, it basically takes the natural language understanding libraries, and on the top of it, it helps you to build, and it gives you a way in which you can extract intents and entities that we spoke of just a couple of minutes ago, and then build your chatbot from that. So it is open source. It comes with built-in pipelines. So anybody who has worked on machine learning, so you will be able to relate to this pipeline in the sense that, so whenever data has to flow through your machine learning model or models, so you take the data, you cleanse the data, you tokenize it, you remove all the outliers, and then you build some models out of it, and that goes through multiple different models, and then finally you have one big model that you want to work with. So Rasa comes with some inbuilt pipelines like that. So this is where the beauty of it lies. So even for people who have not really worked on natural language understanding and processing, can just use this built-in pipelines and then start building a chatbot. And if not, so you are free to go about and then build your own pipelines, wherein you bring your own better algorithms, you bring in your own better libraries, and then you make the chatbot work. So this Rasa basically uses this intent classification and entity extraction for us to help us build this chatbot. So typically, what happens with this is, I have a chat question. So what happens with this is, so it gives, so I given a sentence telling that get me the poster of Batman. So then there is a component of Rasa, which is the natural language understanding, which basically says the intent is poster and the entity is Batman. That's the intent classification and entity extraction. And then there is a component called as Rasa core. These are the components of the Rasa, which basically triggers a corresponding action based on this intent. And in this case, so because now I want to fetch a poster for a particular movie title, so I have written a small Python program which basically goes to, there is this open source library, open source API called as OMDB API, right? So let me pick my browser for all of this. And so now let me say, it is OMDB API. So what these guys have done basically is they have taken the IMDb's open source database and then they have exposed that database as an API. So I'm just using this API. So whatever the chatbot gets, I just extract the movie title and then I hit this API and then get a poster from this and then show the poster back as a response to whoever is interacting with this chatbot and returns back with some posters information. Okay, so, but before I try to do this, I cannot expect, so this is my intent. Yeah? So the intent of this poster bot is basically is to give the poster back. I cannot expect Rasa to automatically understand my intent. So what do I need to do? I need to feed some training data to this NLU, the natural language understanding component of Rasa. And this data will basically help Rasa understand how is a sentence formed and how to extract the movie title, and then it builds on that movie title there. And once we train that Rasa model, then a model gets generated and then we can start interacting with it. So let me show the workings of it. But even before that, let me pause a second and let me look at the chat and if there are any questions there. So for what we have discussed so far, if you have any questions, so we can actually pick those questions there. So right now, there is a question which says, I don't see a pipeline. So comes with built-in pipelines. I was just explaining about this pipeline there. So I did not really show what this pipeline is. When I go to the code, I will actually show that pipeline. So it's a machine learning pipeline there. So that was one of the questions. Okay, so there is one more question about OMDB API. Yeah, so let me quickly do it. These guys from OMDB, IMDb, what it has, I mean, it could have been any application, yeah? So because movies are something all of us can relate with, yeah? So there is no domain knowledge when it comes to searching for a movie, right? So I picked this example. So what these guys have done is, this OMDB API guys, they have taken the IMDb's database and they have exposed this as an API in the sense that now I have my own API key for it. It's a free key. You can get that free key, or you can also donate to this. So if I say, yeah. So now if I say that, say for example, if you look at my browser here, so I use this OMDB API and I'm searching for a movie called as Batman, and my API key is this. So now if I do this, so when I searched for this movie called Batman, you see that this OMDB gave me a list of searches. Yeah? Basically, it's trying to tell me that there is a movie called as Batman Begins, and then there is this poster called as, I mean, this is the poster that this movie Batman has. Yeah? So they have exposed all this movie information as an API, as a REST API for me, and I will hit that API to get that information. So what, I mean, the bot that we are, I'll show you and we will try to build that is, so whenever I figure out that my user is asking for a poster of the Batman, then I trigger my Python component, which basically goes to this OMDB API, meaning it basically hits this API, searches for that movie, picks out these posters, and then returns back that poster. So now this could have been anything for that matter. So you could have written a Python program which goes to your database and then does some number crunching and returns back that number. Or it can go to your, maybe hit the stock exchange and then get a price of a stock price ticker. Right? So it can do any such thing. Or you might also say that I want to book a ticket. So it can also act as a concierge's desk for you, so that you can start booking some tickets from this. So what component you write here, this is the action response. That is the business logic, that is the proprietary business logic that somebody can put in behind these chatbots. Yeah. So I'm just showing one such implementation of it. Pretty easy to extend it. Okay. And also there is a question which says, so every time Rasa needs to be trained to get it working. Yeah, so the thing is, you train once, and this model that gets generated will be used multiple times. So if there is no change in the data, then you don't need to train it. But if there is a change in the data, then you need to train it. So what do I mean by that? You would have trained your NLU based on some formation of sentences, in the sense that, so you will say that, okay, the sentence might come in the form of, get me a poster, show me a poster, show me posters. So you would have anticipated some kind of conversation, and you would have trained your chatbot. But when you really put it into the market, and when you figure out the actual conversations happening, then there might be sentences that you would not have trained your chatbot on. So, and if they are valid sentences, then what you do, then you again change the data so that you train that, okay, so it's not just this kind of sentences, but my users are also asking a sentence which looks a little different to what you have been trained on. So take this new data and then train yourself. So this how often you want to train is basically dependent on how quickly your data is changing. If the data is changing very rapidly, then you would want to train your models very often. And if that's not the case, then maybe you can afford to stay for a month with the same old data, and then you can start doing it. So that's what it is. So it is maintenance intensive also in that case. Yeah. So, and there is a follow-up question there which says, how about a scenario when someone says they've integrated a chatbot? What's the process followed in general? Yeah. So once I show the demo of it, I'll also talk through it. And then there is one more question which says, how can we extract the content or the intent from the text? So that is where the training comes into picture. I will show that data to you, and then we can work through it. All right. So now let me move to my workspace. So I have set this project in PyCharm, and I'll also give you these instructions about how you can go about setting it. And then I'll also tell what is the actual change that I have done to this. Yeah? So not just from, and what else have automatically come to me from Rasa. So even before I start working with it, even before I show you some things there, let us go from a top-down kind of an approach, wherein I will start with, I'll run this chatbot, show an output, and then we will start figuring out how and why this output worked. Okay? Yeah, so now, okay. So now if I, let me start my Rasa chatbot. So I'll just say, so I have previously trained it. Yeah. So anyways, we'll go through those motions of it, but I'm now starting this chatbot. So I typically did not want to go through the route of showing a chat interface, because that may not be the only way you want to work with it. And I wanted to concentrate on the actual ways of working for it. So that is why. Okay. So now you see that the chatbot is up for me, and all the training and all those things have already happened. And you also see that it has also loaded a few NLU components. That's what Rasa is telling. And finally, my bot is up. And this bot is also broadcasting itself on some kind of an API. So if ever I wanted to use this chatbot as just a REST API endpoint, I can still use that. I can build any kind of interface around this. So thinking about it as just a chatting interface is kind of limiting. So that's why I didn't go through that chat route for this demo there. So here, let me say hi. So that was the input that I gave it. Yeah. So now it understood that. So it did some kind of a classification. It understood that this intent was a greet, and then it said, hello, how can I help? And because this is a poster this is a poster bot that we are building. I'm of course interested in getting some posters. So now let me say, get me posters of Batman. So now what happens? Now look at this. There were two kinds of sentences. One was a greet, and it responded accordingly. The other was an information fetch, and it responded accordingly. So what did it do? It figured out that get me posters of Batman was a request to fetch the posters. It figured out that Batman was the entity, but let me see if it really worked correctly. So let me see. If I click on this URL, there you go. So it gave me the posters of a couple of posters of Batman there, and pretty much okay. So that means that it really picked out this Batman, and it did a search on the Omdb API, and that API gave me back some results, and it's showing those results here. So let me do one more thing. So let me say get posters of Superman. Maybe. I don't know. I'm just using work safe searches here. Oh, okay. Yeah. So now what you see here is it really did not understand my second thing. Okay? So we will talk about it. So now it's asking me to take this thing. Let me stop it and start it. I'll tell you why it behaved like that. So keep this in mind when I show the actual workings of it. I'll tell you why it worked that way. Let it come up. So I say hi, and I say get me posters of Superman. Okay, so it hit there, and maybe it has given me the right one. Yeah. And then I said bye. Yeah. So then it went out. Yeah. So now it says that so it figured out a greeting versus an exit versus a fetch of the poster. It understood the intent, and it understood the entity. So now I can again restart the chat. I can say hi again, and then I can say get me posters of and then it goes ahead and does it. So I'm happy with it. I just say bye, and then it exits out of it. So we quickly saw the workings of it, but what goes on behind this? How was this chatbot able to understand what was an intent of greet versus what was an intent of getting a poster versus what was an intent of buy? This is where the training comes into picture. So let me stop the bot. Okay, that's okay. So now what I have done here is, even before I made this chatbot work, I had to train the chatbot on various nuances. So what do I mean by that? So I give some, so there is this, RASA expects us to give some data for the training. So this is the data.json. And in this data.json, so I have specifically said that if something is a hello, then the intent is greet. And this really has no entities with them. And not just that, I have also put other greets also. Yeah, so it's not just hello. Somebody might say hi, somebody might say something else, and so on and so forth. Yeah. So here, what is also important for us to note here is the word that I enter need not exactly match this. So I can also say something like hello there. So this hello there, look at this. This hello there is not the exact sentence that I have trained with. So here I have just trained with hello, howdy, hi there, hiya, and all these things, but not exactly hello there. But still, it kind of understood that this hello there falls under the intent of greet. So it understood that it falls under the intent of greet. So similarly, I have also provided some intents of goodbye. So how does it look? So it can be bye, bye-bye, goodbye, see you, exit, see you later. So these are the kind of sentences that I am expecting my users to typically engage with my chatbot. So tomorrow, if I figure out that my my customers are reacting to the chat in a different way, then maybe I might need to train it again. So then what do? I add a similar kind of training data, and then I say that if this is also one of the inputs, then you understand this as goodbye. So there is definitely a continuous training that goes into this. And for the sake of this example, if you look at my training data, it's just 200 lines. Need not be. I mean, it shouldn't be. So this has to be as elaborate and as diverse and as huge as possible. So hang on to that term diverse. I will come to that, the next thing that I explained there. So similarly here, I have also told that give me a poster of Batman, and then it understood that the intent is a poster message. And in this training, what I'm trying to do in this training is I'm trying to say the intent is poster message, and I have to train it, right? So when I'm training it, I have to make it understand what the sentence is, and then I'm telling it that, so this sentence has the intent of a poster. This text is an intent of the poster, and this poster message, so that's the intent that I have named this intent as a poster message. And then I have also told that it has, so if you look at it from the 20th index to the 26th index, whatever text you extract, consider that as movie. But these numbers need not be the exact location. So a proof in point there is. So if I also say give me posters of Batman, so what you see here is because I added an extra s, because it has a lowercase s, so now it still works. So it just uses that to understand the spaces, how are your words spaced and where it occurs and things like that. So just because I'm giving an index number here, so should not trick us into thinking that it is expecting an index and it has to be only within that. So this, I'm just helping it understand the patterns of the sentences that I have there. So similarly, so there is this, I have put multiple kinds of sentences, all different possible states of sentences, and I had trained this model, and that is why this model, and that is why it was able to return back with some response. But you've not really seen the training part of it. So let me take you through the training part. So now let me stop this. And this is where an interesting thing also happens here. So what I'll do is, I will remove some of the training data from my data.json. So I don't want all the data there. So what I'll basically do here is, so I had used a lot more for the training, right? So let me remove a few of them, and then let us see how this is going to behave. Yeah? So I'll remove it until this. So now it's a new data set, albeit smaller, but I have a new data set with me. So once I have the new data set, now let us see the inner workings of it. Yeah, we'll go one more level deeper. So now that I have this data set here, now I need to train it. So the way I train it is, so I say rasa and train NLU. So I'm not training the whole thing. I'm only training the natural language understanding, just to check if it really understands this data.json well. Now let us see some nice things about how it interacts with me.
So sorry to interrupt, Aditya. We have 10 minutes left, little more than 10 minutes. So if we can speed up, we can as well take a couple of questions at the end.
Yes, yes. Thanks, Valish. I'm almost there. Okay. So now what you see is, so I trained the data. So it took this training data and then it figured out a few things, and then it was able to generate a model. Now look at this. It has stored the model here. Now let me test this. So this is where some nice things lies. So now if I say rasa NLU, sorry, rasa shell NLU. So the previous NLU was an interactive, the previous shell was an interactive shell, but here I'm trying to open, these are commands of rasa. Anyways, I have it in my documentation that I'm going to share with you too. So now it has opened up. This will help me only to test the natural language understanding. So now let me see, now I'll say that get me posters of Batman. This is not really doing the job. It is just helping me understand it. Now look at what happened. So this was the sentence that I gave based on the training data that I had. So it says that it figured out that the intent of this sentence was poster message. And it says that the confidence in this classification, it has classified, right? Whenever it does a classification, there is an element of doubt. Yeah? You might be wrong in the classification also. So it says that the confidence here is 72%. And then it has also extracted the entity, telling that the entity that it has extracted is Batman and the entity is movie. So it has extracted that entity for me. So this is good. So now let me give one more sentence. Yeah? So now let me say, get me the posters of, say, Superman, or maybe, I don't know, maybe then I'll just say hi. Yeah? So now for this hi, it understood that the intent is great and the confidence that this NLU has is 89%. And it basically does a ranking of it when it classifies. Yeah. So it says that 89% I'm sure that it's a great, a 0.06% I think it's a poster message, and 0.03% I think that it's a goodbye. Yeah. And based on the ranking, it tells that, okay, this guy is trying to greet me. So now let me pick one more sentence, that is, get me posters of Batman what? Superman? Superman what? Now let me say, get me posters of, this is where it gets interesting. Yeah? So let me say, get me posters of Bahubali. So when I do this, look at this. It figured out that the intent is a poster message. So there is a 67% confidence that yes, this is a poster message, and I'm okay with it. It is correct. But then look at the entities. It was not able to extract Bahubali. But then if you look at the sentences, it looks exactly same. So it says that get me posters of Superman and get me posters of Bahubali. There is not much of a difference, but still my NLU component could not extract it. So let us see this. Let us see why and how. And so let me copy the sentence. And then, so Bahubali did not work, but at the same time, Superman worked. At the same time, Batman worked. So one might argue that, okay, so in my this thing, Superman, Iron Man are already there. Batman is also already there. Then let me check for Spider-Man. So now if I say get posters for Spider-Man, so here it extracted Spider-Man, even though that was not there in my data set, it extracted this Spider-Man. Yeah, so just a question for the audience there. So why do you think this worked? Why do you think it is fetching the entity for Spider-Man, even though it's not there in the data set, but it is not fetching the entity for Bahubali? Of course, it's not there in the data set, even though the sentence formations were all same. What do you think might be a reason my NLU is behaving like this? Any ideas? Okay, so I have one which says pattern matching a little bit more specific. I have one more answer which says man is common. Okay, maybe. So because I trained all my data set based on Superman, Spider-Man, Iron Man, it thinks that, my NLU thinks that the data always needs to have a man in it. So that is why diverse data is also very important for me to build my training data set. Now what I have done, I have actually made my NLU as a biased NLU. I don't want it to be biased. I want it to be as diverse as possible. So now, then let me put it to a little bit more test. Yeah. So is it really asking about all these superheroes or a superhero of a different kind? If I just say Hanuman, let us see. Yeah. So this kind of gives us. So here, this Hanuman, because it was a part of it, and even that has a man ending in it. So it kind of figured out that this is a movie. So that's why it's important for us to actually have a very diverse data set. So this was just one experiment there. So let me stop this thing. So once we did that, there have been a couple of questions. I will also take that question a little while after this. So
We have
once we
5
did
minutes.
that, yes, thanks, Valish. So once we did that, so now I have better training data set. I do the same thing. I train my NLU. Now let me see whether it picks up Bahubali now, yeah? or anything similar to that also. Okay, so now if I say Rasashal, because I added that back, I added a lot more diverse data set. So now let me see if it works for it. Get me posters of Bahubali. So now you see that it extracted Bahubali. Let me try something around it. Babylon. Yeah, so now you see that. So it figured out that it was able to extract this Babylon also. So that's why a diverse data set is important for us. So once we build that diverse data set, then so that will help us in the natural language understanding. But then there is the second part called as dialogue management. So this NLU was only the natural language understanding. So in the second part of it, so in the dialogue management, there I need to build stories of conversation that are possible. So I say that. So somebody might utter a greet. So that's why it expected me to say hi first. In my dialogue management, it could not directly take a poster. Yeah? So first I had to say hi, because that's how I have built my story here. I say that, I utter a greet. Then on a classification of poster message, I am asking for a movie, and then it extracts the movie, and then I say goodbye. So the story that I have created for my training set is always the format of hi, poster message, goodbye. Hi, poster message, goodbye. Anything else, the chatbot is failing. So there will be two kinds of trainings that we do. One training on the data, that is the natural language understanding training, and the second training on the stories, as in what different combinations of this can happen in my chatbot building then. So that is where some of the common commands that we use. So I just trained it. Training created a model for me, and then I ran the shell. And once I ran the shell, based on the stories, I was able to have a dialogue there. Yeah? So natural language understanding and dialogue management, two different parts of a chatbot building there. So cool. So let me quickly take you through the next part of it. That is, yeah. So I'll take question and answers post this because we are reaching towards the end of it. So post this session, there will be a GitHub link shared to you, which will basically have you, give you all the instructions of from where you download and what are the different prerequisites, what are the different setups that you need to do, and then how do you train the model and how do you run the NLU. And as a takeaway, I also have a couple of experiments for you. I think there's one missing there. So I have a couple of experiments for you. You can just play around with the data. And then, so one is, so different kinds of movie names. You might find that a few movie names are not answering. How do you change that? And then, so how can you correct the dialogue flow, which expects a greeting to start with? So you can actually play around with the stories and the data, and then you can see your chatbot working on the top of it. So this will be one of the takeaways for you from this webinar. And one of the myths that I need to talk about is when you speak of chatbot, we always think of boil the ocean. That kind of gives a bad name to chatbots also. No, a chatbot need not solve all your problems. Chatbots can be domain specific, chatbots can be problem specific, and the chatbot can work only for that kind of a problem. So that is also something that we need to always keep in mind. Chatbots are not they're not a panacea. They cannot answer all your questions. It all depends on how much of a business logic you put behind the chatbot. So that's what matters. You can start with one, but later over the years you can keep extracting it. And the next steps for you from here is take a particular case study, maybe hook it up to a database, maybe make the data dynamic rather than from a text file, and then see how you can build a whole pipeline around this chatbot, and then you would start to have a more production level chatbot then. So two parts to this. Just before we go there, the whole reason why RASA does something like this is the data and the stories. Yeah, you don't need a technology person to do this. You just need a domain expert. Yeah? So when I say domain expert, a customer service representative. So he knows what are the stories he handles. He knows what are the kind of conversation. A technology person might come in and help implement these actions, which is basically hitting this Omdb API and getting the posters, right? So I have created an action, a custom action called as action poster, and it is giving me those posters there. So from a technology standpoint, so we have a clear distinction. I enable as many actions as possible. From a customer representatives or somebody as a business analyst or somebody who is more closer to the customer, they can build this training data and they can build the stories that they want depending on how they want the chatbot to interact with. And tie this up with more ML models, tie this up with a very nice CI/CD pipeline, and then you have a very productive chatbot with you there. So those will be the next steps when we try to work with chatbot. So yeah, so this kind of brings me to the end of this session. So a follow-up communication will come to you. You have already registered through this. And then, so in that, I will send you all the information that is required to start off working with this. Hopefully, this session was fruitful to you and it gave you an insight into how this works. So this kind of brings us to the end of it, but I'm also okay to extend a couple more minutes and I'll take the questions. But if there are people in the audience who are pressed for time, so the session kind of ends here, and I will take the Q&A along with this there. Okay. Yeah. So let me see it. So I have a question which says, can we populate this training data dynamically? Yes. Definitely yes. That is where tying this up with some kind of a CI/CD pipeline will make a lot of sense. So in that CI/CD pipeline, so I can say that so I might say that, okay, there is this script which generates this new training data every month. And based on that, I need to trigger the training. And once I trigger the training, I need to redeploy my chatbot, and then the chatbot can kind of work through it. So that was one of the questions that I got. Are there any other questions? So there was, yeah, so I think that's a popular question. Can the learning be dynamic? Yes, we can. Okay, so two parts to this. So the kind of learning we are making it happen is a supervised learning, wherein we are helping it to classify it. I can make this supervised learning in batches or micro batches for it to happen. So apart from that, RASA as such doesn't really give you a continuous dynamic learning, but we can build it in micro batches in such a way that you take the new conversations, store that information, feed that back into a training data set, so we can do something like this. So we can pick portions of conversation and then mark that as a good training data set for somebody to answer. So that is there. And then that question about, can we populate this data dynamically? Yes, so I answered that question. Yes, we can do that. Superman and Batman results are same. Maybe he was talking about this NLU because it thought that the structure was same. But what is more important is the value that it fetched. So the value that it fetched, the entity fetch, entity extraction. So that was different for Superman and Batman. So one place it took the right name, at the other place it took a different name. Okay, so that is good there. So we are towards the, Okay, so there is one more question which says, let me know why did the server suddenly stop and was not able to take up the request? That is because that is how I have built my stories. So I have built my stories in such a way that the message should always be in this format. The conversation should always be in this format. Greet, poster message, goodbye. Greet, poster message, goodbye. If my chatbot gets it in any other format, it will not know. So that is where improving the stories also come into picture. So maybe I need to have a story which just responds to this poster message. Maybe I need to have a story which can do this poster message multiple times, not just stop at that thing there. So that way we can make this story a lot more user friendly there, because this was just an intro to it. I just have fixed communication type of communication that we do there. Data.json stories. So those are the things that we deal with. Okay, so any more questions on this? So let me see, there is in the Q&A I might have. So all actions post dynamically populating data be automated using CI/CD, in turn linked to the DB. Yes, definitely yes. So the question is about this data, can we actually put it back to the DB and then put the data to be trained? Yes, that is one of the popular ways of setting up a chatbot also. So we take the data and all this data we can, so right now I've only shown you one way of interacting with this. It can also be a form data, as in somebody might give you some information and you might store that information. You might store this chat itself into some kind of a DB. And from that DB, you might actually put it back into your training data set using a CI/CD system. Yes, so those things are possible. And in any production worthy chatbot, so those things will be there. Okay, so that is good. So I have reached the end of this session.